Okay, everyone. So we were looking at the usefulness of inheritance earlier and why we might want to use it. Another extremely useful idea behind object-oriented programming is the development of ADTs, or abstract data types. So when you're going out into computer science or other areas where you might be working with coding, you're going to be faced with scenarios of like, okay, I have a lot of data, and how do I work with that data, and how do I operate on it? And this applies to both CS and computer science and software development. We work with lists quite a bit, but sometimes a list might not be the most effective way to implement data, because sometimes you put items into a list, and the way that we do it is that the first item put in might be the first again. Another idea here, though, is let's say that you're developing a type of a game where you have a queue of people coming into it. A list might not be the best idea because maybe the list might put the person that was added in last. In first, the way that you implement it, and a queue instead is going to operate a bit differently. So what we could say here is that a queue can operate where there'll be a line of people. Excuse me for my drawings here. Just get this copied. Cool. So say that we have a few people, and then they're all in line here. And let's just say that the queue is over the start right here. If more folks come into it, what we would like to do is add in people at the back. And now a list is usually going to add in people here at the front of the queue. And that's not good because let's just say this guy was waiting here for a bit. If this guy comes in and just gets placed into the front, the one behind him is going to be a bit angrier. So this is where this concept of abstract data types comes into play, where we can develop these new forms of data collection and data distribution for our purposes. So in this scenario, we're going to make a queue where a queue is first in, first out container class. So the person that comes in first into a queue is going to be the first one that's going to be left when they pop an item from it. This is very useful. You can consider this like a line at a roller coaster or a line at a theme park. People get into a queue, and the first person into the queue is the first one to leave the queue. Hopefully, unless there's like maybe you could implement like a fast pass system or something. But in general, we're going to do a basic queue here. And what I'll do to get started here is I'm going to create a class called queue, and it's going to implement my object. So again, object is up there just because we're basic with it, or that's what we've been using. And so far, we've only been doing this type of development where we take a look at objects and self.name, self.age. We're doing very basic objects. What we can also do here is create a self.myQ variable, and what we can set that equal to is actually an empty list. And if this is set to an empty list, this allows us to manipulate this myQ variable in a lot of different ways. Now, if I create this self.myQ here, not much will happen. So what I want to do here is actually surround this with an initializer. So inside of my initializer, excuse me, my constructor, I'm going to create an empty list, which will go ahead and be able to contain a lot of items into it. Now, if I go ahead and pop items into my queue here, what I wanted to do is put the items at the very front of my, or the very end of my queue. So again, if I have a queue of items, whoever is at the front over here should be added in. If I want to add in an item or append it, I don't want to add one in at the very end here. I want to put one in front of them. So let's go ahead and try to implement this, and let's see where the issues arise, where I might be encountering some issues with my list structure. So what I'm going to say here is I'm going to create a new method called enqueue, and this is going to take in a self parameter as usual, and it's going to take in an item as well. Where am I getting enqueue? Well, enqueue is over here. It's just like kind of what the layout of this one is. And if I enqueue something, we might be tempted to say, okay, I have a list item right here. Self.myQ I know is a list. If I want to add something into my list, self.myQ.append item. Okay, let's go ahead and see what happens here in my code. So I'm going to go ahead and say q is equal to q, like so. Q.myQ. Whoops. But a. We see we have an empty list here. What I'm going to do now is enqueue. What do I want to enqueue here? I'm going to enqueue something. Let's just say my name there. So I have a John, and now let's just say that this is consider this to be a single person inside of my element, and now let's just say that I'm waiting in line for a roller coaster, and I'm at the front of the queue. What happens if I let's say my dog comes in behind me, and Duchess waits in line with me as well? Uh-oh, it looks like Duchess actually skipped in front of me and went one ahead of my queue. And now I'm upset because I'm behind someone in my queue, and this is going to keep going. So this is where OOP comes into play. Instead of appending the item at the very front of my list object, what we can do here is use this command called insert. And what insert will do, if we actually look at the definition of it there, it won't show me right now, but essentially you can tell insert to put something at a specific index in your list. And if I want to put something always at the start, technically behind me in my list, I can put it at the 0th index, and now I can enqueue my item. Let's see here. So now if I get queued on my queue, I see that I have John at the front there. And now if I do this again, we'll see that Duchess, instead of being in front of me, is now behind me here. So what do I need to do next here in order to dequeue something? Well, if I'm dequeuing something, it doesn't really matter the item that I'm dequeuing. A dequeue or leaving the queue should always be the person that's at the front of the queue, or essentially at the very end of our list right now, right? Because that's how we were looking at it visually. So what we could say here is that if I want to remove someone from my queue, I'm going to need to pop them from my queue. And if I go ahead and just do this type of code here, and let me actually make this, I'm going to show a little trick here. If you do q is equal to q inside of your script, this will actually go ahead and automatically create a variable that you can reference for later. So I'm going to go ahead and try to do this here. We'll see here that I now have oops, excuse me, my queue. And if I do q.dequeue, we'll see now that I left the queue from the front because I'm popping from the end there. Now, if you want to be very specific about this, you can always make sure that you pop from -1, but usually the pop will go ahead and pop it from the end of it. And the reason we say -1 is that -1 is the inverse of 0. So -1 goes to the very end of the list, 0 goes to the top. Let's just try it with pop for the time being. So now I have this queue that's working for me, and it looks like it's working out okay. And what I could say here is a few more commands that are over here. So we have a enqueue, a dequeue, a size. So if I want to get the size of my queue, how do I return the size? Well, what do we remember about my data structure that I'm working with? It's actually a list. So what I could say here is simply go ahead and return the length of self.myQueue. And now, essentially, because it's a list data structure, it's an underlying list data structure, I can use these methods on it. What about our isEmpty? Well, let's see here. IsEmpty is going to return true if it's empty, false otherwise. And what we could say here, essentially, is we are going to look at the size, and we just created a method called size. So what I could say, return self.size is the method call is equal to 0. This is a Boolean statement that will return true or false. Let's go ahead and see if this works. False because it's empty. Q.dequeue. I dequeued my 2 items and now it's true. Nice. So we're getting through this type of queue creation pretty well. And now what I'm going to do here is try to return the representation of these guys here. And what I could say here is let's go ahead and create a representation and a string, pretty printing version of it as well. I'm going to go ahead and return this representation of self. And what I'll say here is return queue item with, and then I'm going to put a blank here, elements. And what I'll say, I'll format it, and I'm going to return self.size. That's going to be my format. Def a string here, and here's where we can get a bit creative here. What I could say here when I have my string is essentially something where I could go, okay, go ahead and say for item in self.myQueue, print item. Let's just say it like this. Or let's try to do print item for the time being. Let's see what happens in our code if we do this. So if I do print of Q, we'll see that I get this Duchess and John printed out pretty well. Those are the two items that are in my queue. If I do my normal queue, I get queue item with two elements, but I get this issue where my string returned a non-string type. So this won't actually work for me for the time being. So what I'll say right here is just this message that says implementing. Nice. And it looks like our queue is working pretty well. And what we would like to do next with this implementation of queue is essentially attempt to do something where I could say for item in queue, print item. So take some time to look through the notes and review how you might attempt to do this in the next one. But in our next lecture, we're going to implement this using our custom iterator and next commands.